Today we're going over adding and subtracting polynomials objectives, and you'll be able, after the lesson, you'll be able to classify polynomials and write polynomials in standard form, evaluate polynomials expressions, add and subtract polynomials. A monomial is a number, a variable, or a product of numbers and variables with whole number exponents. So we have, this is a monomial, even though it has three things happening, it's a monomial because it's only one term. Same for this. This is not a monomial because the -2 makes it into a fraction, so it would be two terms. This is two terms, so it's not a monomial. Again, a fraction is not a monomial because it's more than one term. So monomial is just one term. Now, one term can have multiple things in it, but it's just one term. So the degree of a monomial is the sum of the exponents of the variables. A constant has a degree of 0. So in this case, the degree of this first one is going to be 2 plus 1, so we're going to get 3. Here we only have one variable with the exponent of 1, and here we only have one variable with the exponent of 3. This first one is the 2 plus the 1, but the other one is just one exponent from one variable. Find the degree of each monomial. So the degree of each monomial in this first one is going to be the 4 plus the 3, so that's 7. For B, we have E and D both have an exponent of 1, so it's going to be 1 plus 1, so that's going to give us 2. And this third one, because it has no variable, it's going to be a degree of 0. A polynomial is a monomial or a sum of difference of monomials. A sum of difference is either you add or you subtract different monomials. Now, the degree of a polynomial is the degree of the term with the greatest degree. So if you're going to have multiple terms, like 3x squared plus x plus 2, for example, that's a polynomial. It has different monomials added together. Your degree is just going to be the degree of the biggest term. So this has a degree of 2. So the rules of the polynomial don't apply to the rules as a monomial. For the monomial, you add the exponents because they're in the same term. But for a polynomial, the degree is the one with the biggest exponent. So some polynomials have special names based on their degree and the number of terms they have. So a constant is a 0. You can think of this 0 as like a slope, which you have a horizontal line. So it's a constant, it doesn't change. When it has a degree of 1 or more, so x to the first power is going to be just a line either up or down like this, whether it's positive or negative. Those are the linear functions that we have been working on. A quadratic is, for example, when you have an x squared, the second power means a quadratic. That is a different looking graph. It's going to look something like this or like this. Now, we haven't seen those graphs yet, but that is the name. That will be a quadratic polynomial. Cubic is again x to the third power. Quadric is to the fourth. Quintic is to the fifth. And 6 or more, you do 6th, 7th degree, or so on. Now, in terms, you guys are used to monomial, binomial, trinomial, or 4 or more is polynomial. So for the term names, I made it a lot easier. Monomial is just 1, so we can have xy. Binomial could be xy plus 2. Trinomial could be 2x plus xy plus 2. And then for a polynomial, it could be more terms like 3x plus 2y plus xy plus 2. This is 4 or more, so it will be considered a polynomial. Now, the ones that are highlighted are the ones you will most likely encounter. Now, because this is a binomial for the first one, we don't add the x-axis together. The degree is just 7. And then for the second one, the highest degree, the degree of this one is 3, the degree of this term is 4, and the degree of this term is 0. So the highest degree is 4, so that would be the degree of this polynomial. So for this first term, the degree for this one is 1. The degree for this term is 0. The biggest of the two is 1, so our degree is 1. For this one, our degree is 5 for these terms. Our degree is 5 for these terms. Our degree is 4, and our degree is 0. So our degree right here is 5. So these are our answers for A and B. The terms of a polynomial may be written in any order. However, polynomials that contain only one variable are usually written in standard form. What is standard form? When you have, I'm going to write standard form of a trinomial. So ax squared plus by plus c. Now, why is this standard form? I want you to notice standard form always goes from the biggest exponent to the smallest exponent in degrees. The degree for this term is 2. The degree for this term is 1. The degree for this term is 0. Because C stands for constant, and constant is just a number. And like we've been seeing, a number that's alone has, even though the exponent is 1, it has a degree of 0. And we're doing it based on the variables. Now, if you have a polynomial, it's going to be ax cubed plus bx plus, let's call it cx plus d. In this case, the d would be the constant. The point is the constant is always last. So the standard form of a polynomial that contains one variable is written with the terms in order from greatest degree to least degree. So like I just showed you. And when written in standard form, the coefficient of the first term is called the leading coefficient. So the leading coefficient in both of these cases is A, because that is the leading coefficient. And the leading coefficient, like I said, is always going to be with the biggest variable with the biggest degree. So if you have, for example, 2x squared minus 4x to the fifth, our leading coefficient is going to be negative 4 because it's with the fifth. Written in standard form is going to be negative 4x to the fifth plus 2x cubed. Also, remember, when you have a variable that's alone, the coefficient of the variable is always 1. So if you have an x by itself, it has a coefficient of 1. So this is just good to know because sometimes the leading coefficient won't, the leading term won't have quote unquote a leading coefficient because it's 1. It may not be written, but it's always there. So a variable written without a coefficient has a coefficient of 1. Again, you may have it most of the times if it's a leading coefficient, a variable that's leading and the coefficient is 1, it will most likely never be written in the problem. Now, if you write the 1, that will not take points off at all. That's completely okay. If you don't write the 1, that is also completely okay. Those two answers are correct. So write the polynomial in standard form, then give the leading coefficient. So based on this, we have to find the degree of each term, then arrange them in descending order. To start, it is great to write down the leading coefficients. This is degree of 1, this is degree of 5, this is a degree of 2, and this is a degree of 0. So you're going to put it from greatest to least. So it's going to be negative 7x to the fifth plus 4x squared plus 6x plus 9. Now this is written in standard form. Always from the biggest degree to the smallest. Well, again, once you get used to this and you get better at it, you're not going to need to write all the degrees down. You can just see it and write it. But if you don't, by all means, write the degree. I have no problem with that. Now, we arrange them into standard form. Now, the leading coefficient is going to be that negative 7 because it's the number or the constant that is with the degree. So if you write it in standard form, it's always going to be that first term. So it's going to be the case as long as you write it in standard form. That is the key part right there. So to write a polynomial in standard form, then give the leading coefficient. So the polynomial is y squared plus y to the 6 minus 3y They want us to find the degree of each term, then arrange them in descending order. So the degree for this one's 2, the degree for this one is 6, and the degree for this one is 1. So writing it in standard form is y to the 6th power plus y squared minus 3y. This is going from biggest degree to smallest, so in descending order. And the leading coefficient is 1. It's 1 because even though this y doesn't have anything written in front of it, remember that it always has that 1 in front of it. So write the polynomial in standard form, then give the leading coefficient. So again, our degree is 5, our degree is 8, and our degree is 1. So I'm going to start with the biggest degree. So it's going to be negative 3y to the 8th power plus 18y to the 5th power plus 14y. This is the standard form. And now for the leading coefficient, it's going to be negative 3 because it's the one with the biggest degree. So classify each polynomial according to its degree and number of terms. Now the degree in this case is a degree of 3. So because it has a degree of 3, this is going to be called a cubic. And then now let's look at the number of terms. It has 2 terms, so it's going to be a cubic binomial because it has 2 terms. So B has a degree, so this is 6, this one's 3, this one's 1, and then this one's 0. So because those are the degrees for all of those terms, this is going to be a degree of 6. So it's actually just going to be the 6th polynomial, and it's going to be a polynomial because it's 4 terms. And then for the last one, it's only 1 term. It has a degree of 1. So it's going to be a 1. That's also called a linear degree. And because it's only 1 term, it's going to be a monomial. So today we're going to finish with adding polynomials. Just as you can perform operations on numbers, you can perform operations on polynomials. To add or subtract polynomials, we got to combine like terms. So just like when you add, you combine the numbers, you also subtract, you combine those numbers. Remember, like terms are constants or terms with the same variable raised to the same power. So you can actually add 2x plus 3x to get 5x. Just as well as if you have 3x squared minus 2x squared, you can combine them to get x squared. So numbers, just like variables, you would add them as long as they are like terms. And in the like terms, here are the base of the exponents, and here is just the variables. So to add or subtract, to add, for example, A is solved out for us. We can go ahead and notice the first step is to identify the terms. So we identify them. Here we have a cubed, here we have a square, and here we have a cubed. Notice how in the PowerPoint they're already highlighted in red. The second thing they like to do in the PowerPoint is to rearrange the terms so they are grouped together. So the ones with the p cubed together and the ones with the square together, which just happens to be 1. After we do that, we just combine the cubes, 12p cubed plus 8p cubed to get 20p cubed plus, and then we just write 11p squared left. We can only combine the terms that are together. For example, in B, we have an x squared, we have a constant, we have a normal x, and we have another constant. Now I'm highlighting them right now in colors to identify them. I'm going to rewrite it in standard form. So I'm going to go ahead and do 5x squared minus 3x minus 6 plus 8. Notice how I left the constants together, just to rearrange it just like they did before. And that's the only thing I can't combine. So this would end up being 5x squared minus 3x plus 2. So this would be the final answer. So to this first one, we're going to mark the variables. This is t squared. This is s squared. This is t squared. And this is s squared. So I can go ahead and combine the red ones with the red ones and the blue ones with the blue ones. I'm going to rearrange it just to follow the same steps as before. Now my s's are going to be cursive s's because I mixed them up with 5s. So we're going to get a negative 3t squared plus s squared. This will be our answer for this one. Now this next term, we have an m squared n. We have a second m squared n, and we have a third m squared n. So we can actually just go ahead and combine them, all because they have the same variables. So I can go ahead and combine the first two to get a... Okay, so we're going to combine the 10m squared and the 4m squared to get 14m squared n minus 8m squared n. Then we're going to get 6m squared n as our final answer. So for this first term, we have x to the 8th and x to the 8th. And we have y to the 8th, y to the 8th power. So I'm going to go ahead and combine the x's first to get x to the 8th, and then I'm going to combine the y's to get 6y to the 8th to get my final answer. Now for this third one, it's b cubed c squared, b cubed c squared, and then I have b cubed by itself. So I'm going to go ahead and combine the reds with the reds to get 14 b cubed c squared, and then the other one, since there's nothing to combine with, we just leave it as it is. So here we have an s squared and an s squared and just an s by itself. So I can go ahead and just start combining the s squared to get 5s squared plus s. Now for this other one, we have here a z4, and we have a constant and a constant. So I'm going to go ahead and combine the red ones to get 20 z to the 4th power. And then I'm going to combine the blue ones to get negative 6. Another way that you can add polynomials is by adding them vertically or horizontally. I've shown you how to do it horizontally. Now that I'm going to show you guys how to do it vertically. It's the same idea. The first step is to align the like terms and then just go ahead and add. So here they added the x squares together. Here they lined up the x's by itself, and here they add up the constants to get the 7x squared, the 9x, and then the 3. And then in horizontal form is what we have been doing. We got to use the associative and commutative property to regroup and combine like terms. So we combine the x's, the red, we combine the blues, and we combine the greens, which are the constants. At the end of the day, I'm not going to be picky which way you prefer. As long as you get the right answer, I'm okay with it. I won't be asking you to do vertical addition or horizontal addition. It's up to you which one you prefer. So for this one, example A, they showed you how they did an horizontal addition. They combined the squares, they combined the constants, and then they ended up with 5m squared minus m plus 11. Now, just to do the same, if we were to have done it vertically, I will line up the 4m squared plus, I'll leave a space, and then plus 5. And here we have m squared minus m plus 6. Why did I leave that space? I left this space because we don't have an m term in the first polynomial. So I'm just going to put in a 0 for the vertical. If I were to add it, I get here a 5m squared between these two. When I add 0 and negative m, I get negative m. When I add the 5 and the 6, I get an 11. So we get the same answer. Doesn't matter which way you prefer. Now for B, I'll show you both. We want to add horizontally first, just to follow the same procedure. Here we have xy, and here we have x, and here we have y. So I can go ahead and do 10xy minus 3xy plus x plus y. We can't combine the x and y because they're different variables, but I can go ahead and combine the 10 and the 3's, xy's, to get 7xy plus x plus y as my final answer. Again, if you would have done this vertically, I would do 10xy plus x. And then I'm going to put plus 0 because we don't have a y. And then for the left one, I will do negative 3xy plus 0 plus y. It is important that you line up the terms correctly. If you don't, then this won't work. When I add them, I go ahead and get 7xy. I go ahead and get x. And then I go ahead and get y. Therefore, giving us the same answer no matter which method you use. Just make sure you line them up correctly and you only add the like terms. So for this one, I have an x squared, I have an x squared, I have a y, I have a y, here I have an x squared, and here we have another y. So I'm going to do horizontal addition for this one, just because there's a lot of terms. But I'll show you how to do vertical with it as well. So when I do horizontal, I'm going to go ahead and combine the 6x squared plus 3x squared minus 8x squared. Then I'm going to write the blue ones right next to it, minus 4y plus 3y minus 2y. So I'm going to go ahead and combine these to get 9x squared minus 8x squared. I'm going to combine these to get negative y minus 2y. Then this is going to give me x squared, and this is going to give me negative 3y. So this is your final answer. Now, if you were to have done this with a vertical addition, you have to combine these terms before you can add. So combining these terms, we're going to get negative x squared, and we're going to get a positive y. So when I do vertical addition, I'm going to get 6x squared minus 4y minus 5x squared plus y. So when I add them, I get x squared minus 3y, which again is the same answer. The difference between the horizontal and the vertical here is that you have to combine all of the terms that you can before you line them up. Now this one, let's do together. We're going to go ahead and start. We have an a square, we have an a square, we have a b, we have a b, and we have a constant, and we have a constant. So I'm going to go ahead and put them next to each other. I have a squared plus 3 over 2 a squared plus b minus 4b plus 2 plus 5. I'm going to go ahead and combine the fractions. Since we already have the same denominator, I can just go ahead and add the numerators to get a 4 over 2 a square. I can combine the b's to get a negative 3b, and I can combine the constants to get a positive 7. Now, keep in mind that 4 over 2 can simplify, and it's going to simplify to 2a squared minus 3b plus 7. So, we have an a cubed, we have an a cubed, we have an a square, and we have an a and an a. I'm just going to go ahead and rearrange them together to get a 5a cubed plus 7a cubed plus 3a squared plus 12a squared minus 6a minus 10a. You can go ahead and combine the 7a square and the 5a square to get a 12a squared. A cube, sorry. I can combine the 3a square plus the 12a square to get a 15a squared. And I can combine the 6a and the 10a to get a negative 16a, and this will be your final answer. If you would have done it vertically, you have to combine those two terms to get a 15a square. So you would set it up like this: 5a cubed plus 15a squared minus 6, and then a 7a cubed. I'm going to leave a space because we don't have an a square in the second term, in the second polynomial. And then I'm going to write minus 10a. And then I go ahead and combine them. And I get the same thing. 12a cubed plus 15a squared minus 16a. So it doesn't matter which way you prefer to do it. I just wanted to show you both again. I learned doing horizontal addition. If you feel more comfortable with vertical, go ahead and do it. I don't have a problem nor a preference for this. So subtracting polynomials. To subtract polynomials, we got to remember that subtracting is the same as adding, the opposite. So to find the opposite of the polynomial, you must write the opposite of each term in the polynomial. So when you have a negative and then a parenthesis like we have right here, right? We have to remember that that negative is being distributed to every single term. So this positive 2x becomes negative, this negative 3x becomes positive, and this positive 7 becomes negative. So a difference from the addition, when we had plus a parenthesis, I just went ahead and added like nothing. But if you're subtracting and it's in a parenthesis, you have to distribute that negative. So this is an example. In order to subtract this, we have x cubed plus 4x, and then we have minus and then a parenthesis 2x squared. That negative has to be distributed, so we get negative 2x cubed, and we go ahead and do x cubed minus 2x cubed. Again, these are the like terms. And then we just follow the same procedure as we do for addition. We group them together, combine like terms, and then we left with negative x cubed plus 4y. So we have to subtract these two. So we have 7m to the 4th minus 2m squared minus, and then 5m to the 4 minus 5m squared plus 8. Because we're subtracting, we have to distribute that negative to all of those three terms. So we're going to get 7m to the 4th minus 2m squared minus 5m to the 4th plus 5m squared minus 8. Now I'm going to go ahead and show you the like terms. We have m to the 4, and then to the 4th, we have squared and square, and we have a constant. So having that information, I can go ahead and rearrange it to group them together to get 7m to the 4th minus 5m to the 4th, and then minus 2m squared plus 5m squared minus 8. So doing that, I will get here an m to the 4th plus a 3m squared minus 8. This will be our final answer. Now I'm going to show you guys how to do subtraction using a vertical method. So we have to first distribute that negative to both terms. So we're going to get negative 10x squared minus 3x plus 7 minus x squared plus 9. So when we do the vertical, we're going to grab the squares together, put them right on top of each other. So negative 10x squared minus 3x plus 7, and then minus x squared. We're going to put a plus 0 because we don't have anything for the x, and then plus 9. Now when you're doing a vertical method, after you distribute that negative, you can actually just add them like we did in the previous slides. So you're going to get a negative 11x squared, a negative 3x, and a positive 16. So this will be your final answer. If you guys, again, feel more comfortable doing horizontal, by all means, go ahead and do it. I don't have a preference. Just remember that after you distribute that negative, you can just add as if it were the beginning of normal addition. So since we are subtracting, the first thing I'm going to do is distribute that negative. So I'm going to get 9q squared minus 3q minus q squared plus 5. I'm going to go ahead and rearrange the squares together. So 9q squared minus q squared. Oh my God. Minus 3q plus 5. So this is going to give me 8q squared minus 3q plus 5, and that would be our final answer. Now, if you did it vertically, these are the two terms. So I'll go ahead and do 9q squared minus 3q, and then for the bottom, we're going to do q squared plus 0 plus 5, and 0 on the top. This will give me 8q squared minus 3q plus 5, giving us the same answer as before. So for the last problem of the PowerPoint, we're still going to distribute the terms. So I'm going to get 2x squared minus 3x squared plus 1. And then I will get negative x squared minus x minus 1. I'm going to go ahead and combine like terms. This is a square, this is a square, this is a square. And then we have this is a constant and this is a constant. We're left with just one x that's by itself. So I'm going to go ahead and rearrange it into 2x squared minus 3x squared minus x squared minus x plus 1 minus 1. I'm going to go ahead and combine the terms. This is going to give me negative x squared minus x squared minus x. Combine this, I get 0. So I can combine these two again to get negative 2x squared minus x, and that is our final answer. If you would have chosen to have done the vertical addition, we're going to combine these two to get negative x squared first. So you would do negative x squared plus 0 plus 1. And then here, negative x squared minus x minus 1. Again, the 0 just serves as a placeholder because we don't have an x in the first polynomial. So I will get a negative 2x squared minus x plus 0, which eventually simplifies to negative 2x squared minus x. So the same answer as before. You guys do have homework. It is on Canvas. But that's it for today's class.